So last class, Theo had asked me a question about whether there was always an intervening CH2 group between the double bonds, and I waffled on that point because I don't know everything, and I was thinking about conjugated systems where it goes double bond, single bond, double bond, single bond. You have this alternating, it's called a conjugated system. And the naturally occurring fatty acids are not conjugated systems. And that CH2 group is very commonly intervening. So yes, the observation you made is correct. You can have double bonds in very rare, strange cases. You can have them separated by more than that, but they're typically not going to be conjugated and will have that sp3 hybridized carbon in between. Okay, so last week I had ended by talking about, or last Monday I talked about monounsaturated fatty acids, oleic acid, the principal component of olive oil and peanut butter and other oils. It's an omega-9 fatty acid. What does that mean again? What does omega-9 indicate? Does anyone remember what that means? The double bond is 9 bonds in from the end of the fatty acid, from the methyl group at the very end. Okay, good. And so now the fatty acid tail, the hydrocarbon tail, can have more than 1 degree of unsaturation, meaning that there's going to be more than one double bond in there. And these are what we call the polyunsaturated fatty acids. So here are a couple, 2 or 3 common ones: linoleic acid and arachidonic acid. These fatty acids, and they're shown in their cis configuration, all of them. If you look, the chains are on opposite sides, or on the same side of the double bond for each of them. These fatty acids are found in a host of vegetable sources. Maybe I did talk about this slide. Did I? Palm and coconut oil have it, but it's also found in no. God, Wednesday morning. I'm sorry. Linoleic and arachidonic acid, CLA, GLA. These fatty acids are going to be found in places like flaxseed oil and chia seeds, various nuts. There are some vegetable or animal sources of these fatty acids as well. These particular fatty acids are really important because these omega-6 fatty acids are really important because they serve as precursors for different steroid hormones in the body. And at the end of the day, when you guys wrote all that stuff on Monday, at the beginning of class, about what you did and didn't know about fats, there was a really common theme throughout a lot of that. And there was there are good fats, there are bad fats. A lot of people talked about avocados. Many people said that fats are generally to be avoided and not eaten very much of. And so what I would like to do is try to get you to the point where you see fats not just as good and bad, but why that is and how various hormones, pro-inflammatory and anti-inflammatory hormones in your body are made from these lipid precursors. So we'll see that in a little bit. But arachidonic acid is an important fatty acid in terms of steroid synthesis, hormone synthesis. And then there are omega-3 fatty acids, where the degree of unsaturation is much closer to the end of the fatty acid. So the omega-6 has it 6 bonds from the end, of course, and then omega-3, the terminal double bond is 3 from the end. And we have these icosapentaenoic acid, linolenic acid, which is different than linoleic acid, docosahexaenoic acid, DHA. DHA in particular has a huge number of double bonds in it. The degree of saturation is 6. Unsaturation is 6. There's 6 of these cis double bonds in DHA. And in particular, that amino acid, or that fatty acid, man, my tongue just is not cooperating today, is, pretty hot in the last 5 years in the nutritional supplement industry. You can buy these DHA supplements because that fatty acid is important for brain development and is important for the lipids that make up the membrane in your brain. So have neuroplasticity requires certain amounts of DHA in the diet, either in the diet or needs to be synthesized by the body from other fats. So linoleic, the omega-6, and linolenic acid, both of those have that name because they're derived from, they're found commonly in linseed oil. It's two of the principal fatty acid components of linseed oil. Icosapentaenoic acid, EPA, icos is a prefix that is referencing fish. So it's found in fish oil. EPA is highly concentrated. It's like the good fish oil that you're people who eat cod liver oil. I don't know if anyone here does. But it's good for you. And then there's the DHA. All right. So just like there are essential amino acids that the body really can't synthesize, there are essential fatty acids as well. And these are ones that you have to get from vegetable sources. If you don't, it can lead to a host of problems. So you can have liver and kidney problems. It can reduce the growth rate in children, particularly neuronal development. It can lead to a problem with your immune functioning, because the immune system in general is really driven by one category of hormones called the cytokines, particularly the interleukins, which is a type of cytokine that the immune system, it's basically the chemical control system for the immune system. Those hormones are driven by their downstream aspects of linolenic and linoleic acid. And then it can lead to other manifestations such as depression, has been linked to low dietary consumption of the essential fatty acids, the omega-6 and omega-3 fatty acids. Pretty commonly, dry skin is also associated with that. So another thing I didn't put on the list is atopic disease. So atopic disease is essentially a type of allergy where the types of atopic disease I'm talking about are atopic dermatitis, otherwise known as, which is a type of eczema, atopic rhinitis, which is like hay fever. It's a type of, it's a runny nose, that kind of thing. And asthma. all have components of those diseases that are affected by the essential fatty acid content in the diet. That is not to say that that is the cause of those problems, but it does exacerbate and interact with those disorders. Yeah, Hannah. The two that I'm highlighting out of that list. So that list is just a subsection of that larger list that I showed last time. The other ones are ones that can be made from, if you have linolenic and linoleic acid in your diet, you can make the other ones. You need the other ones as well. And so if you don't have the essential fatty acids, you're not going to have enough EPA or DHA in your body, assuming you're not eating EPA or DHA in some other dietary source, right? To get those, you need to have ALA or the linoleic acid. Does that make sense? I mean, you can eat EPA and DHA and get that in the diet, and not eat linoleic or linolenic acid. But it's going to lead to some other issues for you. So what's the upside of having a diet that has the appropriate levels of essential fatty acids? Well, it's going to prevent atherosclerosis. So last year I talked about blood lipids much more, and I got more into the physiology of it. I cut that out this year. Maybe I'll put it back. I don't know whether you want to hear about it or not, but really understanding fats and what fats you should eat, and what they're doing for you, how important fats are, because it's a pretty common misconception that fat is bad. Low-fat diets are good, and that you should avoid fats. That's not correct at all. It's about having the right kinds of fats in the body to help yourself be healthy. But there are certain fats you should avoid, and I'll talk about that in a bit. But say you're eating fats, highly saturated fats, a lot of saturated fat that is driving your blood lipids in one direction, that may in exclusion of these essential fatty acids lead to atherosclerosis. If you then include these essential fatty acids, you can prevent that, or at least lower your risk for arterial plaque formation. That's what atherosclerosis is. Athero just means blood vessels, sclerosis, hardening of your arteries. And as part of that, having a diet rich in linolenic and linoleic acid, you're going to have a reduced incidence of stroke and heart disease because you have a reduction in atherosclerosis. It can also help people with ulcerative colitis, people with menstrual pain, people with arthritis of various sorts, and these that line there, those different maladies are could be broadly painted as a group that are inflammatory in origin. Of course, menstruation is not a pathology itself, of course, but having excessive pain associated with it is, as is ulcerative colitis. It's a inflammatory process. Joint pain is an inflammatory process. So these fatty acids, having a rich source of these particular fatty acids in the diet, can lead to the production of sort of anti-inflammatory cytokines in the body that keep these processes more under control. And omega-3 fatty acids, ALA, is really the one that is super important in the diet and is dramatically lacking in the typical American diet, sadly. But it has been associated with a decreased risk of breast cancer, which is just a scourge. It's just a scourge. Okay, so the having linoleic acid, LA, in the diet, the essential fatty acid. From that, you can then produce all of these other omega-6 fatty acids. So I don't know who asked me that question there, but yeah, so you can make conjugated linoleic acid, the GLA and the arachidonic acid can all be made from linoleic acid. And we get this from leafy greens. It's in seeds, nuts, different grains, and certain vegetable oils. So sunflower oil, corn oil, soy oil, safflower oil are sources of omega-6. The American diet is not radically lacking in omega-6. Most people, and when by most I mean like 70%, 80% of people out there, get adequate supplies of omega-6 fatty acid in their diet, in the foods that they eat. But I'm going to evolve that story in a moment. Then we're going to look here at the omega-3 fatty acids. This is really a problem. So from ALA, alpha linolenic acid, this is where you can make the other omega-3 fatty acids. So the EPA and DHA, which those two, the EPA and DHA, are really crucial in terms of neuronal development, and they're the ones that are going to have, so you'll remember that those two fatty acids were the ones that had the really high degree of unsaturation, like 6 different double bonds in the chain. And those are going to be really important for the production of steroid hormones, as we'll see. Maybe I'll save the tangent for when we get there. We can find that in these foods that you see here. So nuts, particularly walnuts, are really high in omega-3 fatty acids. You can find it in soy. Squash, the various vegetables in the squash family are pretty high in omega-3. One of the absolute best sources that you can get in omega-3 fatty acids are in small, sort of what I would call ancestral seeds. So seeds that have been part of the human diet for since prehistoric times, very, very long times. And these include flax seeds, chia seeds, hemp seeds. All 3 of those are really high in ALA. Seaweed is also extremely high in ALA. Certain beans are very high in not as high as those seeds, but have reasonable quantities in them. The best source that you possibly can get for this is in those seeds that I listed, or seaweed. Those are really exceptionally good sources, and you can get at the. I went to the dining hall last night. You can get flax, chia, and hemp seed all at the salad bar here in the dining halls. So you have access to it. All right. So the thing about the fats, is the omega-6 and the omega-3, isn't just the bulk quantities that you're getting of them. It's about the ratio that you're having of omega-3 to omega-6. So that ratio that has been sort of determined by epidemiologists and physiologists, so people who are looking at human disease and correlating it with diet, and people who are studying basic human metabolism, and nutritionists, they have concluded that the ideal ratio is about 1 to 4, or 1 to 1, or up to about 1 to 4 omega-6 to omega-3. So you need typically more omega-3 fatty acids than omega-6 fatty acid. And the problem is in the typical American diet, It's flipped, and radically so. So most Americans get 10 times more omega-6 than omega-3, 10 to 25 times more omega-6 than omega-3. That isn't to say that they're eating too much omega-6. It means they're not eating enough omega-3 fatty acids in their diet. And what happens is when the omega-6 fatty acids are such a huge component of your diet compared to the omega-3s, the omega-6 fatty acids sort of outcompete, the omega-6 fatty acids outcompete the omega-3s and sort of replace them in the various niches in the body. Yeah, David. Well, I would say it was probably the 20th century, right? It was when that first really started happening, when people moved from like agrarian-centered life, where they were producing, where farming was not industrialized, and the diet was, more whole foods that were being prepared at, in the home, that had more direct connection to vegetables, less meat-centric diet, where meat was a bit of a luxury. And then in the 20th century was the rise of industrial agriculture and processed foods. With the Haber-Bosch process, suddenly you could grow a shitload more cows and pigs than you could before, because we couldn't feed them before. Now we had industrial agriculture, so meat became a much larger part of the American diet. And then the way we were growing, so that is the story of this slide here, the way we are growing the meat is also important. I'm not doing it this year, but last year I did this experiment where I had the students take little samples of their hair and put it into one of those tins like you did for the elemental analyzer, and analyzed the students' hair. And you can look at the carbon-13 to carbon-12 and then N14, N15 nitrogen ratios in your hair, and tell how much corn is in your diet, and whether you've been consuming grass-fed or corn-fed beef. And it correlates with where you've lived. Like people from Asia have different profiles in their hair. People from Europe have different profiles than North America. Anyways, when you look at beef that has been produced in Europe compared to beef that's been produced in the United States, and you look at the omega-3 to omega-6 fatty acid ratio that's found in that meat, the omega-3 to omega-6 fatty acid ratios are radically different. Okay, please keep me on track with the time. I don't know where my phone is.
It is 9:30. Basically 40 minutes.
Okay, you just tell me when it's time. And that's because the ratio, the underlying ratio of the lipids in the feed that the beef is getting is different in corn versus grass. The grasses have a much higher omega-3 fatty acid content. So there is an actual, it's not just a woo-woo touchy-feely thing when you talk about grass-fed versus corn-fed beef. There is an actual nutritional difference between the two of them. And while it's true that the ratio is still not ideal in European beef, meaning your diet should not exclusively, this should not be your exclusive source of the omega-3 and omega-6, the essential fatty acids, that ratio should be flipped. It's significantly better than corn-fed beef, and in fact, this the rise of corn-fed beef and industrial agriculture here in North America that's based upon corn is really at the root of the ratio in the typical American diet. So it's a problem. It's a real problem that, you know, most people aren't really talking about in the general public, because it takes, you know, you have to listen to someone lecture about omega-3 and omega-6 fatty acids for 20 minutes to even be able to wrap your head around that for most people. So, but the take home is, if you're going to eat beef and you have a choice, try to not eat a lot of beef for a number of reasons, but grass-fed beef is better for you. So yeah, also just try to eat minimally processed foods that are going to have a higher concentration of these naturally occurring omega-3 fatty acids. All right. So what would you guys say? We know that avocados and this fish right here is, I think that's an alewife. Which, has anyone ever had an alewife? Yeah, you have. Any of them? We're coming up. Maybe that's the field trip we should take down to Damariscotta to see the alewife festival, not the ale house, the alewife. Yeah, it's pretty amazing. Down in Damariscotta, you can see there's like more fish in the river than water. It's incredible. Millions of these fish migrating.
Damariscotta.
In Damariscotta, yeah.
How far away is it?
It's about maybe an hour. Which of these two foods do you think, how do they compare in terms of their fatty acid profile? If you were going to guess, and you were going after the most juice per squeeze in terms of getting the best profile of healthy fats, would you eat an avocado or a little bit of cold, oily fish? Sounds yummy, huh?
So I say fish.
Okay,
I'll put my money on the fish.
Who's with Graham?
Wow.
Okay, we got 2, 3, all the guys 4.
Fish.
Alex and David, you're sticking with the women in the class. Everybody else is for the avocado. All right. Yeah.
Whatever. It's a little extra flavoring.
Yeah, there is a little bit of mercury. So, yeah, fish is hard to beat. A cold water, oily, small fish is really hard to beat in terms of the lipid profile that you get. Not only are you getting, a comparable gram per gram amount of the ALA. So an avocado does extremely well in terms of ALA compared to the fish. It has about 80% of what you're going to get out of a piece of fish. But the fish begins to shine because it has significant amounts of the EPA and DHA as well in them. But, that's all assuming that you get a chunk of fish that doesn't have mercury in it. Okay. Yeah. Okay. Now I'd like to look at nutritional labeling just a little bit and see what you can learn from nutritional labeling, and then see how, given what I've talked about in terms of essential fatty acids, how inadequate nutritional labeling actually is in this country. So here are a bunch. So I guess on the right is a typical nutritional label, right? And it's for butter. It's for butter. And what does it say on a normal thing? Well, it's going to tell you the serving size in grams. It's going to give you the number of calories per gram. And I'm going to give you a calorie lecture sometime maybe next week where we actually talk about how a calorie is. But calories from fat, all of them. So butter is mostly fat. And if you look down the thing, you can see total fat there. Out of 14 grams of a serving size, 12 of those grams are some kind of fat. and it tells you that it tells you the amounts of saturated fat, and it tells you the amounts of trans fat. So of the 12 grams, 8 grams in butter is saturated fat, and it says, well, none of them are trans. That's great. It does talk a little bit about the cholesterol, sodium, potassium. That's there for people who are trying to watch their sodium, who maybe are hypertensive. And it talks about carbohydrates, the total carbohydrates, the fiber and the sugars, and then it gives you protein. We can assume that the 2 grams in butter that is not fat is probably water, and maybe a little bit of, if it's not fat or cholesterol, it's maybe water, and I don't know. Doesn't seem like there's anything else in there. So 8 grams of saturated fat. That would seem to indicate that there are 4 grams of unsaturated fat. But what does that mean? I've just shown you that huge list of all these different fats and how the types of fats that you may have, the types of unsaturated fats, are going to have different implications in terms of your health. It's not even, didn't even explicitly tell us the amount of unsaturated fat that's in there. We had to infer that number by subtracting saturated fat from total fat. So on the left here, I have a sort of a more comprehensive breakdown of the fats, the categories of fats that you can find in various foods. So the saturated fats are, and again, these are mixed lengths. They can be short, they can be long. Various lengths are in red. And in general, you want to try to keep saturated fats down in the diet a little bit. They tend to be associated with animal fat or higher temperature fats. So fats that are high in saturation tend to be fats that are have a higher smoke point and are often used for cooking. So palm oil and coconut oil are both often used in cooking. And if you think about that, the source of those fats, palm oil and coconut oil, where do those foods grow? In the tropics, right? Yeah, in the tropics. Whereas, does anyone know the largest producer of canola in the world? What is canola? What is canola? What's that? Yeah, it's rapeseed. That's right. And the word canola comes from, I think it's actually an abbreviation for Canadian Oleo Association or something like that. It's like the CAN is for Canada. So canola, rapeseed, grows very well in Canada, as does safflower and flaxseed. Sunflower does real well up in these northern climes, but less amounts of saturated fat there. Those northern clime fats have more unsaturated fats, but if they're unsaturated, the danger is they're heat sensitive, right? They're heat sensitive because you can take a cis fat, and if you heat it too much, you can turn it into a trans fat, right? And we've talked about how trans fats, in particular, the body doesn't know how to deal with trans fats, and leads to foam cells that form plaques, arterial plaques in the body. All right, so let's look at butter. Butter has a large amount of saturated fat, meaning it's actually not too bad to use as a cooking oil. And then the majority of the unsaturated fat that's left is monounsaturated, oleic acid, omega-9. So you're not really getting a whole lot of your essential fatty acids out of butter. Just a teeny tiny amount of omega-6 and virtually none of the omega-3. That is so important. So let's then look at some other oils. Say we were going to compare safflower oil, or let's compare safflower oil and flaxseed oil. Safflower oil is a very common oil that you'll find, Crisco or whatever you can buy on the shelf to cook with, or you put over your salad or something like that. And at first pass, if you were looking at the nutritional labels of safflower oil and flaxseed oil, they would look identical practically. They have about the same amount of saturated fats. They would have the same amount of total fat, so they wouldn't really look any different from the standpoint of the nutritional label. However, when we compare the relative quantities of omega-3, 6, and 9 fatty acids, this is where the difference really comes through. There's a huge relative amount of omega-3 fatty acid in flaxseed oil, where there's virtually none in safflower oil. Yeah. Okay, thanks. We will pick up there next time. I'll talk about why saturated and unsaturated fatty acids are different. Yeah.